Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 29th of mathematical physics, in which I'm going to discuss Laplace transform. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start, and this is I'm going to start Laplace transform. Okay, so this is Laplace transform. Okay, so Laplace transform. So Laplace transform is used. It is used to solve ordinary differential equation. Ordinary differential equation without calculating without calculating without calculating arbitrary constant and general solution Okay, so it is used to solve ordinary differential equation. How? Without calculating arbitrary constant and general solution. Okay, so Laplace transform of fx, Laplace transform of any function which is a function of x is going to be, we can write fs, that is going to be integration minus infinity, my apology, it's in integration 0 to infinity 0 to infinity fx e to the power minus sx dx. Okay, so this is the Laplace transform of any function, f integration 0 to infinity fx e to the power minus sx dx. Okay, right, and this one, limit x tends to infinity e to the power minus sx fx value is finite. Okay, okay, so now I'll write an important thing like this is integration minus infinity to plus infinity x to the power m e to the x to the power m e to the power minus alpha x to the power n. Okay, so this is the integration minus infinity to plus infinity x to the power m e to the power minus alpha x to the power n. This value is equal to 2 integration minus infinity to plus infinity, my apology, it's 0 to infinity, we have break the limit. Okay, so 0 to infinity, okay, x to the power m e to the power minus alpha x to the power n. okay, dx. This value is equal to this value. There is a condition: if m is even and n is also even, okay, or this value is going to be 0 otherwise. Okay, so if m and n both are even, then this we can break this limit 0 to 2 into 0 to infinity x to the power m e to the power alpha x to the power n dx. Okay, and here important formula which you need to note down, okay, which will help you to solve integrations. Okay, so this is 0 to infinity 0 to infinity x to the power m e to the power minus alpha x to the power n. Okay, this is very important formula. 0 to infinity x to the power m e to the power minus alpha x to the power n. Okay, both m and n are even. Okay, this value is going to be this value is going to be 1 upon n 1 upon n. Okay, 1 upon n gamma m plus 1 upon n, okay, upon alpha to the power m plus 1 upon n. Very important. Okay, so integration 0 to infinity x to the power m e to the power minus alpha x to the power n, this dx, this value is going to be 1 upon n gamma m plus 1 by n upon alpha to the power m plus 1 by n. Okay, very important formula. This will help you to solve complicated integrations. Okay, okay, so now the Laplace, I'll write formulas for Laplace transform. Okay, so you need to note down. So Laplace transform of 1. Laplace transform of 1 is 1 upon s. Okay, 1 upon s. Laplace transform of 1 is 1 upon s. 1 upon s. Okay, next is Laplace transform of e to the power ax. Laplace transform of e to the power ax. This value is 1 upon s minus a. Okay, next is Laplace transform of x to the power n. X to the power n, and this is going to be n factorial upon s to the power n plus 1. N is integer here. Okay, and s is greater than 0. Okay, so Laplace transform of x to the power n is n factorial upon s to the power n plus 1. Well, and now Laplace transform of, very important formulas, Laplace transform of cos ax. Okay, Laplace transform of cos ax. Laplace transform of cos ax is going to be s upon s square plus a square. Okay, now Laplace transform of sin ax, this is going to be a upon s square plus a square. And now Laplace transform of sin hyperbolic x, sin hyperbolic ax. Okay, Laplace transform of sin hyperbolic ax is going to be a upon s square minus a square. If hyperbolic is there, then s square minus in denominator you will get s square minus. Okay, and with just a sign, then it is s square plus. Okay, in the denominator. Okay, so similarly the Laplace transform of cos hyperbolic ax, this value is going to be s upon s square minus a square. Okay, so Laplace transform of cos hyperbolic ax equal to s upon s square minus a square. Okay, very important formulas you need to note down and memorize it so that we can solve questions. Solve question using these formulas, so these formulas are automatically going to be memorized. Okay, next is linear property. property. Linear property, okay, of Laplace transform. So we have fx equal to, we can write fx equal to, this is a1 f1x plus a2 f2x plus so on, right? So Laplace transform of fx is going to be a1 Laplace transform of f1x plus a2 Laplace transform of f2x plus so on. Okay, this is the Laplace, this is the linear property. Okay, next is scaling property. Okay, that is scaling property. Scaling, okay, scaling property is Laplace transform of, okay, so it's scaling properties Laplace transform of f(ax), okay, Laplace transform of f(ax), it is going to be 1 upon a f s upon a, okay, this shifting property. So Laplace transform of f(ax) is going to be 1 upon a f s upon a, okay. Now shifting property, very important, shifting property, shifting property is Laplace transform of e to the power ax fx. E to the power ax fx is going to be f s plus a, okay. Laplace transform of e to the, this is going to be f s minus a, guys, okay, f s minus a. So e to the power Laplace transform of e to the power ax fx, this is going to be f s minus a, okay. Similarly, Laplace transform of e to the power minus ax fx, e to the power minus ax fx, this is going to be f s plus a, f s plus a, okay. This is linear property, this shifting property. Next is next is scaling property is done, okay. Next very important, this very important property, that is Laplace transform of fx upon x, okay. So any function upon x, okay, Laplace transform of any function upon x is going to be integration 0 to infinity, okay. This is no, this integration is going to be integration infinity to a, integration sorry, my apologies, it's integration a to infinity, integration a to infinity, okay, and that is fs ds. Very important property. I will solve one question, okay. I'll show you that this property is very important, okay. So this is Laplace transform of fx upon x is integration a to infinity fs ds, okay, or this is not a, this is s to infinity, this is s to infinity, okay, s to infinity fs ds, okay, important property, okay. Next property is Laplace transform of any integration, okay, integration 0 to x, okay, 0 to x or 0 to t, integration 0 to t, and this is fx dx, okay. So this is the integration 0 to t limit and fx dx, and the Laplace transform of integration 0 to t fx dx, this is going to be 1 upon s 1 upon S Fs. Okay, 1 upon S Fs. 1 upon S Fs. Okay, this is the property Laplace. This is the property of any integration. Okay, so if we have to find the Laplace transform of any integration with limit this, right, this is going to be 1 upon S Fs. Okay, next property is, this is also very important property, Laplace transform of x to the power n fx. Okay, Laplace transform of x to the power n fx. So this is minus 1 to the power n dn over dxn, or d to the power n over dx to the power ds to the power n fs. Okay, so this is the property, important property. Okay, so Laplace transform of x to the power n fx is going to be minus 1 to the power n dn over dsn fs. Okay, this is the property. Next is, okay guys, these are the properties, important properties. Now I'm going to solve questions. Okay, question is, first question, is Laplace transform of cos square ax. Okay, cos square ax. Okay, so you need to find the Laplace transform of cos square ax. So these using the properties which I have explained. Okay, these properties and these properties and these properties. Okay, okay, so we are going to solve it. So it is cos square ax. So we don't have this property, right? So what we are going to do is we'll use identity formula. Okay, so we know cos 2 theta equal to cos square theta 2 cos square theta minus 1, right? So from here cos square theta is going to be cos 2 theta plus 1 by 2, right? Cos square theta value is going to be cos 2 theta plus 1 upon 2. So we'll use this formula here. So this is going to be Laplace transform of 1 plus cos 2ax. Okay, 2ax upon 2 2ax upon 2. Okay, so this is going to be 1 into, so this will be 1 upon 2, we can take common. Okay, 1 upon 2 Laplace transform of 1 plus 1 upon 2 Laplace transform of cos 2ax. Okay, this one cos 2ax. So Laplace transform of 1 I have already explained here, right? So this value is, Laplace transform of 1 is 1 upon s. Okay, and similarly Laplace transform of cos 2ax, here we will use this formula, Laplace transform of cos ax, right? A value over there is 2a. Okay, right? So this is s upon s square plus a square, right? So a is here, it is going to be s upon s square plus 2a whole square, right? Because instead of a we have here 2a. Okay, so we'll write, so this is going to be 1 upon 2 Laplace transform of 1 is 1 upon s. Okay, 1 upon s, this one 1 upon s plus 1 upon 2 Laplace transform of cos 2ax is going to be, cos means s upon s square plus 2a whole square means 2 square plus a square, right? 4a square. Okay, this is the one, or we can write, that implies 1 by 2 s, so this is 1 by 2 s plus 1 upon 2 s into s square plus 4a square. Okay, this is the answer, guys. Very simple, formula based. So you need to practice question as much as you can using these formulas, guys. Then these formulas will be in your fingertips automatically. So you need to practice, guys. Practice questions using these formulas. Okay, next question. Question number 2. Okay, question number 2 is this is Laplace transform of x sin ax. Okay, x sin ax. This you need to find out. These are simple questions. So Laplace transform of x sin ax. How we are going to solve it? We have this formula, right? I'm showing you so that, okay, this one, Laplace transform of x to the power n into fx, right? So this is going to be minus 1 to the power n d to the power n upon dsn fs, right? So here here we have just x to the power 1 is here, right? So this is going to be minus 1 to the power 1 d upon ds, this, right? So the formula is going to be, if x is here, so this formula will be minus 1 using this formula. Okay, if x is here, then this formula is going to minus 1 to the power 1 means minus 1 d to the power 1, right? It means d upon ds fs, right? We'll use here. So this is going to be this one. This is going to be minus, because we know this formula, minus 1 to the power n dn upon dsn fs. Okay, so this is going to be because this is for x to the power n, right? So this, for here x to the power is 1, so it is going to minus 1 d over ds fs. Okay, d over ds fs. So here minus 1 means minus d over ds and fs. Fs means Fourier transform of fx. This is fx here, guys, right? This is fx. Okay, so this is fx. So Fourier transform of this one, Fourier transform of sin ax is going to be this. Fourier transform of this going to be this fs value is this is sin, right? Sin means a upon s square plus a square, right? This one here you can see sin ax equal to a upon s square plus a square. Okay, so just put the value. So this is going to be minus d upon ds. Now we'll differentiate it. Okay, so minus a will take common. This is d upon ds, and this is how we are going to solve it. So this we can say this is t. Okay, so we can write like this: s square plus a square to the power 1. Okay, so we can say s square plus a square is t. Okay, the simple differentiation. So minus a, and this is going to be minus. So this is minus 1, right? So this is going to be minus 2 minus 1. Sorry, yeah, minus. This is going to be, this is minus 1, right? So this is going to be power s minus 1. So it's s square plus a square to the power minus 2, right? And x to the power n means minus n x to the power minus n minus 1, right? So 1 minus 1 minus 1 minus 2, and this is in then differentiation of this 2 s square plus a square, so this is 2s, right? So this value is going to be, Laplace transform of x sin ax. Okay, so this value is going to be minus will be plus. Okay, and this s square plus a square whole to the power minus 2 means it will go in denominator, so this is going to be 2as upon s square plus a square whole square. Okay, because s is here, right? So this is the answer, guys. 2s s square plus a square whole square. Okay, next question. Question third is Laplace transform of sin x upon x, right? This is the property we have, right? This we need to find out. Okay. So Laplace transform of sin x upon x, I have already explained, that is integration s to s to infinity fs ds, right? I'll show you this property. This one, Laplace transform of Laplace transform of fx upon x. Okay, this value is integration 0 s to infinity and fs ds, right? So here instead of fx we have sin x. Okay, so this is going to be, so this so sin x, so fs of sin s, what is so we know the Fourier transform of sin x. Fs means, we know fs means that's my apology, Laplace transform of sin x, and this value we know, right? This is 1 upon 1 plus s square, or 1 upon s square plus 1, right? So this is going to be Laplace transform of sin x upon x equal to integration integration s to infinity 1 upon s square plus 1 ds. Okay, now this formula we know directly, 1 upon s square plus we know, right? 1 upon integration 1 upon x square plus 1 dx is tan inverse x, right? So similarly 1 upon x square plus 1 upon s square plus 1 ds is going to be that is tan inverse s, right? So this value is going to be Laplace transform of sin x upon x, Laplace transform of sin x upon x, this value is going to be tan inverse s and integration s to infinity, okay, not minus, s to infinity. So this value is going to be, so this will be tan inverse infinity minus tan inverse s. Okay, tan inverse infinity value is pi by 2, guys. Okay, so pi by 2. Okay, so infinity value is 10 pi by 2, and this tan inverse infinity value is pi by 2 minus tan inverse s. Okay, and this value we know, this value is cot inverse s. Okay, because we know tan inverse, this one, tan inverse x plus cot inverse x is pi by 2, right? This we know. From here this value is cot inverse s. Okay, I hope you understood it. Now next question we are going to solve. Okay, let me just check whether I'm audible or not. This is very important part.
Okay guys, these are the problems.
Yes, I'm audible. So I'm going to proceed further. Next question is, this is we are talking about periodic function. Okay, periodic function is, this is f x plus nt. Okay, fx plus nt equal to fx, if it comes like this. Okay, this is called periodic function. This is called periodic function. Okay, and Laplace transform of fx, which is periodic. Okay, that value is going to be 1 upon 1 minus e to the power st, 1 upon 1 minus e to the power st 1 upon 1 minus e to the power st, okay, e to the power st, and then integration 0 to t, integration 0 to t e to the power minus sx, e to the power minus sx fx dx. Okay, so this is Laplace transform form of fx is going to be 1 upon 1 minus e to the power st, e to the power minus st, guys. 1 upon 1 minus e to the power minus st, and this t is the time period, okay, and integration 0 to t e to the power minus sx fx dx, okay. And so now I will give example, okay. I'll solve examples. Question is, as example, question is fx equal to x square, okay, fx equal to x square, okay, and which is where x is between 0 to 2, okay, and f x plus 2 equal to fx means period is this means time period is time period t equal to 2, okay. So now we'll find Laplace transform of fx. This is going to be 1 upon 1 minus e to the power minus st, e to the power minus st, t is 2, right? So e to the power minus 2s, e to the power minus 2s, integration 0 to 2 e to the power minus sx, fx is x square dx, okay, this one. Next, is this is going to be Laplace transform of fx is going to be 1 upon 1 upon 1 minus e to the power minus 2s e to the power minus 2s, and this we are going to solve this one, right? This is going, so this is will solve by integration by part, right? This is first function and this is second function, okay. So this is going to be first function x square, integration of second, so this is going to be e to the power minus sx, so e to the power minus sx upon minus sx upon minus s minus this one second, that differentiation of second, that is 2x, and integration of this one, right? So this is going to be e to the power minus sx, and again the integration, right? First it is, this is second function, integration of second, and then again integration of second, right? So this is going to be 2x e to the power sx upon s square, okay, plus this 2 differentiation of this, because x is square, right? Differentiation of this is 2, and then integration of this function, so this is going to be e to the power minus sx upon s cube minus, okay, and the limit is going to be 0 to 2. Very simple integration. So it is going to be 1 minus e to the power 2x, okay, e to the power 2s, my apology, yeah, e to the power 2s, e to the power minus 2s, e to the power minus 2s, and this value is going to be, we'll put the value, so this is going to be 2 means 4, 2 to the 4, right? E to the power minus 2s upon minus s minus 2 to the 4, x value is 4, right? E to the power minus 2s upon s square minus 2 e to the power minus 2s upon s cube, okay, because minus will be there, okay. Now minus this value is going to be 0, because limit is 0, x is 0, this value will also be 0, this is minus, minus minus going to be plus, this is going to be 1 upon s cube, because e to the power 0 is 1 upon s cube. My apology, it's 2 upon s cube, because 2 is also here, 2 upon s cube. Okay, so well, so this is the answer. 4 e to the power minus 2s upon minus s minus 2 minus 4 e to the power minus 2s upon s square minus 2 e to the power minus 2s upon s cube plus e2 upon s cube. Okay, so this is the answer, guys. Next question. Next question is next question is Laplace transform of Laplace transform of delta x minus a. Okay, this is Dirac delta. Okay, Dirac delta x minus a. This we can solve it. So this is going Laplace transform of this. So this we know, right? This is the function. Laplace transform of any function is minus 0 to infinity, right? E to the power minus sx fx, that is del x minus a dx. So here you can see x is a value is between 0 to infinity, right? A is a one value integer, and which is between 0 to a, obviously, right? So we will use Dirac delta property. So this is going to be e to the power minus as, e to the power minus as, right? Because we know if this is the condition, this will be, know, right? If this one, if this value is 0 to a, or right, fx delta x minus a, or this is 0 to 2a, right? A is between 0 to 2a, right? So it means the property is fa, that is fa. Okay? This is Dirac delta property. I have explained Dirac delta property in detail in my mathematical physics, right? So you can check that course. Okay, that class, yeah. Okay, so this is the simple integration, and so this is the answer of delta x minus a. Next question is Laplace transform of sine 2x upon x. Okay, so this is simple, right? So same, this is fx upon x, right? So it's integration s upon infinity, okay, fx sin x, and oh sorry, fs ds, right? So fs ds, so fs means the this one Fourier transform of sin x. Fourier transform of sin x, we know, right? That is this is going to be 2ax, right? 2 is here, 2 upon uh, s square plus 4 ds, right? This is the Fourier transform of fs sin 2x, right? Now this integration is very simple. This is going to be 2 into 2 upon 2, right? This is 2 upon 2 tan inverse s upon 2. Okay, this is the simple integration, and then this is 0 this is s to infinity. Okay, and these two are going to get cancelled. So this is going to be Laplace transform of sin 2x upon 2. This is going to be this one, 2 is cancelled, so this integration is tan inverse. We'll put the value, so this is going to be tan inverse infinity. We have put the value, okay, tan inverse infinity minus tan inverse s by 2, tan inverse s by 2. Okay, so tan inverse infinity value is pi by 2 minus tan inverse s by 2. Okay, and this value is going to be cot inverse s by 2. This I have already explained. Okay. Well, now this is the question. Okay. Next question is integration 0 to infinity sine t upon t dt. Right. This I have already in Fourier series or Fourier transform. I have write the formula for this, and I told you that you need to memorize. I have written this value of this integration right directly, and I told you that you need to remember because that is very important, right? And this value I have told you. So 0 to infinity sine t upon t dt, or 0 to infinity sine x upon x dx. This value is pi by 2. Okay, I told you, and now I'm going to derive it from. I'm going to explain it and derive it by Laplace transform. Okay, how we've got pi by 2. So we have to find out Laplace transform of this. Okay, so no, so we have to find out value of this. Okay, so how we are going to find? So we know Laplace transform of sine t upon t, right? This we know. I've already told you. So Laplace transform of sine t upon t is going to be integration 0 to infinity e to the power minus st, e to the power minus st, and this is a function, right? So this is going to be sine t upon t, right? Like Laplace transform of fx is sine t upon t, right? Integration 0 to infinity e to the power st sine t upon t, right? Next, we'll find this Laplace transform of sine t upon t. We know, right? That is integration s to infinity fs, right? Fs of Laplace transform of sine t upon t, that we know, right? This is fs means this is the fx, right? This is t. So ft sine t means 1 upon s square plus 1. So this is going to be 1 upon s square plus 1 and ds, and this value is 0 to infinity. Well, as it is, that is e to the power minus st sine t upon t. So with Laplace transform, we can solve many integration very easily. Okay, whose limit is between 0 to infinity. So very important. Sine t upon t dt. Okay. So here now what we are going to do is putting s equal to 0 on both sides. 0 on both sides. Okay, putting s equal to 0 on both sides. So this is going to be integration 0 to infinity 1 upon s square plus 1 equal to 0 to infinity e to the power 0 s equal to 0 e to the power minus 0 and sine t upon t dt. So s square is going to be 2 1, right? 1 s equal to 0 will put, so this is going to be 0. This is ds. Okay, next is here this first will put the value. Okay, 0 to s square s square plus 1. Okay, s square plus 1, right? So this is going to be now what we'll do is we'll put the value. So this is going to be tan inverse s integration 0 to infinity, and this value is going to be integration 0 to infinity sine t upon t dt. Okay, this one. So we'll solve this. So this is going to be tan inverse. This means write in next page. Tan inverse this value is going to be tan inverse infinity minus tan inverse 0, right? Minus tan inverse 0. This is going to be equal to this value, okay? Integration 0 to infinity sin t upon t dt. So this value is going to be pi by 2, and tan 0 value is this is tan inverse 0 value is 0 equal to integration 0 to infinity sin t upon t dt, right? So this implies integration 0 to infinity sin t upon t is going to be pi by 2. You should also note down this and memorize this formula, very important formula. Many integration you can easily solve if you know this formula, okay? Well, next question. Next question is, this is done, right? Next question is integration 0 to infinity, okay, and t e to the power minus 3t sin t dt. Okay, this integration we have to find. Very good question. Okay, this one. So this also we can solve like this. Okay, so integration this is going to be, first we'll find Laplace transform of t sin t. Okay, t sin t, Laplace transform of t sin t. So this value is going to be, if we get this type of question, right, we'll write e to the power separately and these together. Okay, so I will find the Laplace transform of t sin t. This we know, right? T sin t, this value is integration 0 to infinity t sin t fx e to the power minus st e to the power minus st dt, e to the power minus st dt, right? This is the formula we know, right? E to the power minus st dt. Okay, so now Laplace transform of this, guys. You know what is the Laplace transform of this? This we know, right? That is this one, minus d upon dt, and fs, d upon dt, this one minus d upon dt, fs value is sin t value is 1 upon s square plus 1, right? This value is going to be integration 0 to infinity t sin t e to the power minus st dt. Okay, so we'll solve it. This is going to be 2s upon s square plus 1 whole square. I have already explained how you should. This is going to be s square plus 1 to the power minus 1. If we take in numerator, then we will differentiate it. Okay, so this is the value. So this value is going to be e to the power 0 to infinity t sin t e to the power minus st dt. Here what we can do is, we can put s equal to 3 on both sides. Okay, putting s equal to 3 on both sides, s equal to 3 on both sides. So this is going to be s equal to 3 on both sides. So this is going to be we have put. Okay, so S means 2 into 3, 2 into 3, 2 into 3 upon 3 square plus 1 whole square. This is going to be this one, integration 0 to infinity t sin t e to the power st, right, e to the power 3t, e to the power minus 3t, e to the power minus 3t dt. Okay, this value is going to be this, and then this value is going to be integration 0 to infinity t sin t e to the power minus 3t dt. So this value is going to be 6 upon 3 square plus 1 means 10 square, right, 10 square, right. So this is going to be 3 by 50 because 10 square is 100. We'll cancel it by 2, both numerator and denominator. So this value is 3 by 50 answer. Okay, next question, guys. Okay. Next question is also a good question. Okay, question is Laplace transform of sine root t. This you need to find out. Okay, so here guys, if because we know Laplace transform of x to the power n, right. So this is going to be n factorial upon s to the power n plus 1. Suppose this is Laplace transform of x to the power m, which is not integer, which is in rational, or which is in fraction, then this is going to be gamma m plus 1 upon s to the power m plus 1. Okay, this you need to know. This is gamma, guys. Okay, m plus 1 and s to the power m plus 1. M is not integer. M is not integer in this case. Okay, so now the value of sine root t is going to be, we can open it. Okay, so it's root t, we know how to open sine t, root t upon root t cube upon 3 factorial plus root t to the power 5 upon 5 factorial plus on, right. This is the expansion, so we can write sine root t, very important question. Okay, is t to the power half minus t to the power 3 by 2 upon 3 factorial plus t to the power 5 by 2 upon 5 factorial plus so on, right. We can write like this. So this is going to be sine root t, and this value is going to be, now we'll use this one, Laplace of x to the power m, and m is fractional numbers, right. So this is going to be this t to the power half, right. Laplace transform, let me take Laplace transform. Okay, Laplace transform of sine root t. This is going to be Laplace transform of t by half minus Laplace transform of t to the power 3 by 2 upon 3 factorial plus Laplace transform of t to the power 5 by 2 upon 5 factorial plus so on. Okay, so this is going to be this gamma 1 by half plus 1, okay, upon this one gamma m plus 1 upon s to the power m plus 1. Okay, s to the power 1 by 2 plus 1. Okay, similarly this is going to be gamma 3 by 2 plus 1 upon 3 factorial s to the power 3 by 2 plus 1. Okay, plus This is going to be gamma 5 by 2 plus 1 upon 5 factorial s to the power 5 by 2 plus 1 plus so on. Okay, so then this is going to be Laplace transform of sine root t is going to be 1 by 2. Okay, gamma this we know, right? There is a formula, guys. This one I will write here, gamma n plus 1 equal to n gamma n. Okay, this one. So this is going to be 1 by 2. So this is going to be 1, this is 1 by 2, this is going to be n gamma n, right? So this is going to be 1 by 2 gamma 1 by 2. Gamma 1 by 2 value is pi, right? So this is going to be 1 by 2 root pi upon s to the power 3 by 2. Okay, minus this value is going to be 1 by root 3 will remain as it is. This is gamma 3 by 2 plus 1. This is going to be 3 by 2 gamma 3 by 2, right? So 3 by 2, gamma 3 by 2 is 1 by 2 into root pi. So this is going to be 1 by 3, 3 by 2 3 by 2 into 1 by 2 root pi upon s to the power 5 by 2. Similarly, 1 upon 5 gamma 5 by 2 plus 1 means 5 by 2 gamma 5 by 2, right? Gamma 5 by 2 is 3 by 2 1 by 2 gamma root pi upon s to the power 7 by 2, right? This one. So this value is going to be Laplace transform of sine root t. Laplace transform of sine root t. Sine root t is going to be, this one is going to be, we'll put the value, right? This one 1 upon 2 5 by 2 3 by 2 1 by 2 root 5, right? So this value is going to be, if you simplify it, so that this value is going to be, here we can take root pi s to the power 3 by 2 common. Okay, root pi upon s to the power 3 by 2, s to the power 3 by 2 if you take common, so this value, and half also will take common. Okay, half, yeah, this complete common, this here it is remaining 1 by 2, 1 only, 1 minus 1 by 2 square, 1 by 2 square into 1 upon s plus 1 by 2 to the power 4 into 1 by s square into 2 factorial. Okay, plus 1 to the power 4. Okay, so if you do it, right, so this is what we are going to get. Okay. So here this is the one, so value is going to be now, so we can write 1 upon 2 root pi upon s to the power 3 by 2. Okay, and this value is going to be e to the power minus 1 upon 4s. Okay, if you do that, so you will get this value. Okay, because we know, or we can write like this. First I'll write like this and this will be easy for you. 1 upon 2 square s. Okay, and 1 upon 2 to the power 4 s square, this is going to be s square 2 factorial. Okay, and so on. So this is going to be 1 upon e to the power minus 1 upon 2 into 1 upon 2 into 1 upon s. Okay, this because we know this is the expansion of this. Okay, so this is going to be 1 upon 2 s to the power 3 by 2 root pi, and this value is going to be e to the power minus 1 upon 4s. Okay, yes, so this is the value 1 upon 2 root pi upon s to the power 3 by 2 e to the power minus 1 upon 4s. Okay, Laplace transform of sine root t. Okay, so this is the answer, guys. Okay, very important, you need to note down. So using this, we'll solve one more question. Okay, so this is s by 3 and okay. Next question. Before that, I'm going to write something formulas. Okay, so here Laplace transform of f dash x. This is going to be s Laplace transform of fx minus f0. Okay, and similarly Laplace transform of f double dash x. This is going to be s square Laplace transform of fx minus s f0 f naught s f naught minus f dash 0. Okay, similarly Laplace transform of f triple dash x is going to be s cube Laplace transform of fx minus s square f0 minus s f dash 0 minus f double dash 0. Okay, similarly Laplace transform of f 4 times x, this is going to be s to the power 4 Laplace transform of fx minus s cube f naught minus s square f double dash, my apology, f dash 0 f dash 0 minus s f double dash 0 minus f triple dash 0. Okay, so similarly here Laplace transform of f n x, this is going to be Laplace transform of f n x is going to be this is going to be s to the power n Laplace transform of fx minus s to the power n minus 1 f0. Okay, minus s to the power n minus 2 f dash 0. Okay, minus s to the power n minus 3 f double dash 0. Okay, plus so on. These are very important formula, guys. Okay, so Laplace transform of f n x is going to be s to the power n Laplace transform of fx, then s minus s to the power n f0, then f dash 0, f double dash 0, and so on. Okay, so now I will solve one question. Okay, this is we have to find Laplace transform of cos root t upon t. Okay, Laplace transform of cos root t upon root t. Okay, this we need to find out. So here we know here we know Laplace, this one, right? Laplace transform of sine root t value we know. Okay, you need to know. So here we'll find d upon dt sine root t. Okay, so differentiation of sine root t. So this is going to be 1 upon root t cos root t. Root t cos root t. Okay, so from here Laplace transform of sin t sin root t. Okay, this is this values we have already found, root pi. So this value is root pi upon 2s 3 by 2 e to the power minus 1 upon 4s. This one, right? This one, root sin t. This value, okay. So this is this. Now Laplace transform of f dash t. This one, differentiation of this. Okay, f dash t is going to be Laplace transform of cos root t upon 2 root t, right? So Laplace transform of cos root t upon 2 root 2 root Laplace transform of cos root t upon 2 root 2 root 2, right? This is going to be s fs, right, minus sf0, right? So this is going to be fs means Laplace transform of f fx, right, ft, right? So this is going to be this value we know, right, into root 2 pi. Fs is Laplace transform of ft, right? That is sin root t. So root 2 pi upon 2 into s to the power 3 by 2 e to the power minus 1 upon 4s. Okay, and this value is going to be f0 is going to be 0. If you put this 0, sin 0 is 0, right? So this value is 0. So this value is going to be Laplace transform of cos root t upon 2 root t. This value is going to be s into root pi upon 2 into s to the power 3 by 2 e to the power minus 1 upon 4s. 2 will get cancelled, these are constant, right? So Laplace transform of cos root t upon root t. This formula we have used, right? F dash x equal to Laplace transform of fx minus f0. Okay, so this value is going to be 2 will get cancelled. Okay, s will get cancelled with this. This is going to root pi upon s. Okay, because s will cancel root 3 by 2 by root s. Okay, and e to the power minus 1 upon 4s. E to the power minus 1 upon 4s. This is the answer, guys. Okay. Well, guys, so this is about Laplace transform. Okay. So before ending the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. Thank you, guys. Thank you so much. Bye now.